Hello everybody, welcome back. This is lesson 4.3, part 2. We're going to talk about reference angles. What is a reference angle? It turns out that whatever angle you have, you can use a smaller angle, a reference angle, a smaller angle that's between 0 and 90 to find the values of your original larger angle. Okay? So, for example, here's an angle, right? So let's say that angle is 150, right? Well, it turns out that this angle right here, right next to it, would have to be 30, right? So why don't we use the 30, because as you'll see, with the exception of the sine, it's going to have the same values as 150. Yes. So for the notes, we're going to refer to as the angle is theta, but the reference angle, theta prime, okay? So that's the reference angle. So what would be the reference angle for this? It'd be here. So the reference angle is always made with the x-axis, right? So here's the angle. The reference angle is this little one right here. Look how big this angle is. Well, we can just use this little angle right there for the reference angle. So you have to be careful. This one, since this is 180, if this is 150, this is 30. Since this is 180, since this is 193, then you have to subtract the 180 to get this. The whole thing is 193. And if you take away the 180, you have the 13. This is 322. So the whole thing is 360, the circle. So 360 minus 322. So this angle must be 38. If you think about it, you can figure out the reference angle by using 180 and 360. So the point is, every angle you draw has a reference angle. Okay? So to find the trig function of any angle, first figure out the reference angle, then find the trig functions of the reference angle, then determine the sine. Okay, so the only difference between these two angles is the sine. Maybe. They could both be positive, or one positive, one negative. Okay? But the value, the number part, will always be the same. The angle and the reference angle. Okay? Now this little thing on the side here is it tells you what signs to use. So obviously here, if your angle is here, then everything is positive. But if your angle is here, right, the sine is positive, but the other two, cosine and tangent, they're going to be negative. And if your angle is somewhere here, right, then your tangent is going to be positive, the other two are going to be negative. And then if your angle is here, then your cosine is going to be positive and the other two negative. Right? So you're thinking, how am I supposed to memorize all that? Well, somebody made this cute little sentence to make you to help you remember. So notice that in each one of these, there's only one positive, the other two are negative. So all, sine, tangent, cosine. All are positive, sine is positive, tangent is positive, cosine is positive. All students take calculus. That's how you can remember which is positive. Then, going this way, right? Then all the other ones are negative. So the other thing you have to remember is the special triangles 30, 60, 45. Okay, we did this in 4.2. So here's how it helps us, or how we use it. Okay. Sine of 135. What is the sine of 135? Well, if you draw the angle, it'll be right in there, right? So what would the reference angle be? The reference angle would be this little piece right here. So 135 to 180 is 45. So all I have to do, see, I didn't memorize 135, but I memorized 45. So now all I have to do is think of sine of 45. What was the sine of 45? Opposite of hypotenuse. So that would be this, right? Now, I got it. I'm done. That's the answer. Wait, I thought we were looking for sine of 135. That's the point. The sine of 135 is the same as sine of 45, except maybe the sign, positive, negative. Right? Well, let's check. All students take calculus. All students. Sine. Sine is positive here, so it stays positive. I'm done with that. Here's another example. Tangent of 120. 210. Where is 210? 210 has to be here somewhere. So what would the reference angle be? 180 all the way to 210, that would be 30. So tangent of 210 is the same as tangent of 30. Let's work on tangent of 30. Well, here's my 30-60 triangle. This is the 30 up here. So tangent would be opposite over adjacent. 1 over square root of 3. 1 over square root of 3. I rationalize it at square root of 3 over 3. I'm done. Tangent of 210 is the same as tangent of 30, which is square root of 3 over 3. But wait, do we have the right sign? Is this positive or negative? Let's check. All students take calculus. Take. T. Tangent. Tangent is positive here, so it stays positive. We haven't seen one that's negative, huh? Maybe this next one. Oh, look, this next one is in radians. So I'm telling you right now, you could figure it out yourself, but 30 is pi over 6. So where is 7 pi over 6? Well, 6 pi, right? 6 pi, or 1 pi, pi is at 180. So if we're going from 6 to 7 what is the reference angle? This is 7 right here. Right? 6 7 This is the reference angle. So that must be 1/6 pi. The reference angle is 1/6 pi. So I'm really looking for sine of pi over 6. And I recognize that as 30 degrees. Okay? If you didn't know it was 30, you just use the calculator to change it, right? Times 180 over pi. So sine of pi over 6 would be opposite over hypotenuse. Opposite over hypotenuse. That would be 1/2. But wait. It's negative 1/2, right? So you write down half first. And then you realize all students take calculus. We're here. Take, T. Tangent is positive here. The other two are negative. So sine has to be negative here. Okay? Now I know I'm throwing a lot at you, but it is definitely connected to 4 too. So you had to know that pi over 6 was 30. You had to know that 6 pi or 1 pi is 180. So 7/6 pi is just a reference angle of 1/6 pi, pi over 6. Okay? Then, working with the same thing, we can give you just one value and you can find the others. Right? Figure out which quadrant it is first. That's the most important part. Figure out which quadrant you're in. So if I say that the tangent of some unknown angle is 5 over 12, and the sine is negative, less than 0 means negative, which quadrant are you in? Well, tangent is positive and sine is negative, right? All students take. T is positive. So it must be the third quadrant. Where am I? Here. It must be here. You must be here. Because here, tangent is positive and sine is negative. So you must be here. This is the angle. Now, tangent is opposite over adjacent. So that would be your y over x. Wait. That would be your y over x. So this is y, this is x. So since tangent theta is y over x, I know this is y, this is x. So now I can find sine. But wait, doesn't sine have r in it? I know it's y over r. Well, step aside and do r. Remember how we got r with the Pythagorean theorem? X squared plus y squared. Do it really quick, and you get r, 25, 144, 169. R is 13. So there you go. If y is 5 and r is 13, there must be 5 over 13. But wait, it's negative 5 over 13, because sine is negative in this quadrant. So I got tangent, I got sine. Now I can get cosine. Cosine is x over r. And I already know r. So it's 12 over 13. But it's negative 12 over 13 because we're in this quadrant. And only tangent is positive here. Okay? So here, we give you the value of one of them, some information. We give you information, and you should be able to find all the other two. Okay? All right. So, periodic functions, values repeat after regular intervals. Right? So, if we're going in a circle, you can imagine we're going to repeat. Right? We're going to repeat the same values. So sine and cosine are periodic every 360. So every 360, right, would be the same values. For example, 5 degrees. Sine of cosine of 5 is the same as sine of cosine of 365, is the same as the sine of cosine plus 360 on top of that. So every time you come back, it's going to have the same value, sine and cosine. It turns out that tangent doesn't repeat every circle. It repeats every half circle. So that means 0 and 180 are the same, right? Here, 0 and 360 are the same. You got to go full circle for sine and cosine. For tangent is so. For example, if we're going full circle, it's 30, then 30 plus 360, then 30 plus 2 times 360. We did this, right? 30 plus 3 times 360, coterminal, right? So all of these angles are going to have the same sine and cosine value. Think about it, because it's going to have the same reference angle. And of course, you got to be able to do fractions. So pi over 4, right, plus a circle is plus 2 pi, plus 2 circle is plus 4 pi, plus 3 circles is plus 6 pi, and you got to be able to put those together, okay? Pi over 4 plus 2 pi is 9 pi over 4, etc. So here's an example. Cosine of 11 pi over 4, well, wait a minute, that's way over one circle. So why don't we bring it down? Why don't we take away a circle? So 11 pi over 4 minus 2 pi, use a calculator, is 3/4 pi, right? So now I know 3/4 pi is negative square root 2 of 2, right? Because you can find it where 3/4 pi is. Okay, well, you can put that in the calculator, but you can do it a couple of ways. Okay, let me show you another example. So you find this on the grid, and you find out that this is a 45 triangle, a 45-45 triangle, and then you figure out which quadrant, and you'll see that you're in a quadrant that has to be negative. Let me do a couple more examples because I'm looking at the time here. So the most important thing is the most important thing is that you bring it down to a smaller angle than full circle, then a big, then more than a circle. Well, actually, this is kind of less than a circle. This is negative. So I don't like working with negatives. So if I add a circle, I get back to positive. So 2/3 pi, negative 2/3 plus 2, right? You do the math, and it comes out to 4/3 pi. Now, I know thirds is 60s, so I use the 30-60 triangle, and there you go. I got the answer. Now, again, I know I'm going fast. When we go over the notes in class, we'll slow down, but you can also repeat. You can freeze and repeat what I just said and maybe get it. Another example, 19 pi. Well, that's way over a circle. So if I take away a circle, it's 7/6 pi. And I know 7/6 pi is the 30-60 triangle, right? So it's negative 1/2 over square root 3 over 2, right? And you do the math, and it comes out to 1 over negative 3. Okay? So I think if you have a calculator and you want to check your answer, just put tangent of this, and you'll get the answer. But really, we're dealing with 30-60 triangles, and this is the angle 30 degrees. Okay? And, so you're going to rationalize the answer, and it becomes that. So could you try these problems? Figure out the sine and the cosine of these angles. Okay, if you feel more comfortable with, which you really shouldn't, you shouldn't change them to degrees, but they're all 30, 60, 45 triangles. This is 45, this is a 60, and this is a 30. Okay, when you bring it down to the reference angle, you'll see that it's 45, 60, and 30. Okay, so do the best you can. Make sure you copy everything. And please come to class with lots and lots and lots of questions, okay? Trust yourself. Trust me. This will get clearer. Okay, see you in class. Bye.